Howdy 330ers, this is Professor Kaufman, and this video will try to cover the coding day exercise that we missed, the practicum of putting together a somewhat realistic program in Python. It's a good idea to study coding techniques that others have used. I've definitely benefited from at least examining other people's codes, but also watching live streams. In some cases, I learned some new tricks. In other cases, I learned things not to do, or became thankful for not doing that. The application that we'll attempt to construct is a primitive spell checker. The idea here is there's a text file, it has some misspellings in it, and we want to produce some indication of those spell checks, but then those incorrect words, perhaps by spitting out a new output file that marks each of the incorrectly spelled words, but also to potentially provide a more refined version of this that allows correction of the words in the output file. And that's actually going to be an opportunity to demonstrate use of several Python techniques, regular expressions to parse through the string, as well as higher order functions that allow us to drop in some additional functionality and select it. It's a common pattern that I've seen used in my own code, as well as, well, I mean, it could be I've used it in my own code because I've seen it elsewhere, particularly the Emacs text editor uses that technique quite a bit of. Here's a function to drop in this case, to call to customize behavior. So to give you sort of a concrete idea is, okay, I'll have this gettysburg.misspelled.txt over here. I'll run some Python program on it, and it will use that in combination with an English dictionary to produce some checked version of this, where in our first pass, at least, any of the misspelled words are demarcated with the little double asterisks surrounding the words there. I don't show any sort of run of that program here, but it was generated by the solution that I coded up last week. And so it's going to be a great exercise to see if I can remember what tricks I had to use to pull this out here. In all likelihood, I'll be checking on some documentation as well along the way, just to show that I don't remember everything, and so we'll oftentimes have to Google for some details. But the fact that I remember what exists in Python, or should exist at any rate, that's going to be a great boon here. So I will zip over here to my version of this, my favorite text editor, Emacs. I have a semi-complete version of this in the code pack I distributed along with some of the data files. I'm going to zip into this inner in-class directory, though, to get started. Certainly, we'd want to keep the data in mind. So in this case, there's the text file that has some misspellings in it, as well as then there's a dictionary here of I downloaded from someplace a long time ago. You can see it's in DOS format. Horrendous, but no matter there. It is a list of all the English words that are correctly spelled according to someone's rendition of it. This one has 119,000 entries in it. So, it's of reasonable size there. Okay, so to get started, we'll need a Python file. For consistency, I guess I called it spell check, so I'll call it in here spell check.py. I could, at a first gasp, and this is the way I had initially developed it, work directly with this file. But it actually would be more convenient to sort of work on this first as like, okay, we'll take a string in that represents the thing, and then work through it line by line, and then sort of adapt that to make use of in a sort of file context. So one of the techniques we'll use is something called a slurp, which is just read the entire file into a string and then process it as if it were a string. That's not particularly efficient for large files, but for our sort of dim purposes here, we'll be fine. So let's see. I'm trying to decide right now. I'll just call this input to begin with. And I'll use the triple quote syntax in Python to say this is a string that may contain line breaks. The little backslash here allows me to get a line carry for free, so this thing actually is left aligned over here. And then, let's see, in terms of function decomposition, I'm probably going to start out with this as a sort of monolithic thing, and then as I want to spin some things out, I'll do so. So I'll start with just a spell check string. And this will take an input string over here. And just to make sure we're tracking right, I'll print out input over here and just return input. Okay, so a couple things we can do then to start up a tight interactive loop of development will be to fire up a shell over here and then fire up Python. So I'm pretty sure I'm in the right directory. Yeah, spell check. Okay, so I'll start up Python here. And of course then I'll want to import this module, import spell check. And then I could do something like spell check dot spell check string, and there should be a spell check dot input in there. And as expected, this thing works more or less as intended. So here the call printed out the input string that's passed in, spellcheck.input, so module here, and then also returns the checked string, sort of as is there. Now, as I'd make changes, like, oh, it's going to be annoying to deal with this printing here, so I want to comment that out. You'll note that, okay, I might have to quit Python and come back in and blah, blah, blah for that. There are a couple tricks for this, as you'd want to work with modules and reload them in the interactive loop over here. The one that I think is salient for the moment is to import, okay, I'm going to have to check this part. It's actually in the notes over here, which is good. Import lib, or actually like this. There's a function called reload that's in this that allows you to reload a module so that as you'd make code changes, you don't need to exit the interactive loop. It'll actually refresh the code for use there. Now, there's several ways to set up this one up, but I think it's useful to know about this one. So from import lib, import reload. With that change, then I can reload the module, which is spell check. And this gives me some sort of return value, which is apparently like the module itself. So if I were to recall that history item, now instead of printing, it will blop this thing out over here. It's just the sort of output here. So there are a couple ways then that I can make use of that, and for instance, like plop this down here. Now we get just sort of a single printing or something like that. But I've set up a framework so that later on I can just run the file or the string from the file like into this thing, potentially do other things. This is not exactly a great application architecture, but we're looking for speed just to test out some elements here for the moment. Okay. Next, let's address, now we've got a sort of ergonomic environment to like try something and then see what the results are, try something and see what the results are. The next step is to start worrying about, well, what's the actual logic of using this thing here? And one obvious jump is, well, regular expressions are probably going to factor into this in some way. So a first pass at this would be to say, let me select a regular expression and then divvy up this string, like based upon that. So that might look something like the following. I'll probably need the regular expression library, so I'll bring that in, import RE. And then for some sense of clarity, I'll set up here the regular expression. Let's see. Regex equals, I'll use those raw strings here. Now I have to think a little bit about what this might look like. I'll try something like the following. Obvious choice, word characters. So over here. So that'll be my regular expression. Of course, now I have to figure out how to use it. Obvious choices would be, okay, I could split on this to say, split up. Oh, actually, split would be bad. Maybe I'd want to split on white space there. But splitting on white space would include commas. We could split up on non-white or non-word characters, but actually, I don't really want to spell check 1863. Okay. So, let's see here. Let's see. Oh, I'm sorry. We'd probably want to use find all. Rather than split. So we don't need an inverse. That's like we find all on word characters here. Irritatingly, like this is going to give me back numbers here, but that's okay. So let's just start out with that, like all matches. And if I remember right, this will be re.findAll, my regular expression, and my input. Let's see, I'm not going to want to print necessarily here, so let me in a loop, like for lm in all matches, let's see, I'll call it m. For m in all matches, I will print m. Yeah, I think that's all right. 'Cause I just want to see what the matches look like on the string here. Return the input, and I won't print this time. Okay, so I made the change, so I need to reload, and then we can run this thing. Spell force here. Oh, I forgot to save. That's important. Spell check here. Oh, did I mean? Let's see, R. It was regex. Sorry. Let's see, nice try, Python. You guessed, but that wouldn't actually be right. I didn't mean RE, I meant regex. Here. Okay, cool. So then we got all these buggers. Now, this is relatively small data, and there are a couple things that might not jump out in this already. Certainly, you can see like these 19 and 1863. You don't necessarily want to spell check numbers, so that would be good if we could filter that out of the input in some way. The other thing that's not immediately apparent is there are words that wouldn't be captured with this. It's a great speech, something like this. So the isn't part there as a contraction, I don't think we're going to match the single quote, and so that's bad mojo. We'll miss that. If I save and reload and run that one more time, yeah, we get the splitting here. So that part is, okay, we could maybe finagle that with the right regex, like could do something like this. I can't remember. At any rate, it's actually a good idea at this point to sort of say like, oh, if I could get this thing in, then I could split by words. In a second, we'll deal with the dictionary part of this. But one of the important parts of this is that, well, how am I going to reconstruct the string based on this parsing out of finding all matches in here? And that actually leads to, oh, I don't, because I'm missing all of the spaces and so forth. I don't even know, like, I could try to say, like, this word up here, agoo, is misspelled, but the context is lost of, like, what would I put in over there? So it turns out after you think about it a little bit while, findAll to sort of get a list of the words here isn't going to play out particularly well. And so you'd have to sort of go back to the drawing board a little bit. It would certainly make it easy to spell check each of these words, but not to reconstruct some approximation for the original document, as it were, the text file, with the misspelled word reinserted in there. Now, at this point, you'd have to sort of backtrack a little bit and start thinking about, well, what is a good way to do this? And in most cases, what you might sort of arrive at is you could try to mutate this and should be the sort of natural way that a reader would sort of scan through and find like, oh, this thing here is misspelled, so I mark it like as such. But strings in Python are immutable, so we can't go in and shift these things around. What we can do is to assemble a new string. Where, as we would consider words and find they are spelled appropriately, then we can sort of move on and say, I'm consuming all of this stuff, like this stuff was all spelled fine. Then we arrive at this thing and say, like, this one's no good. Let me take this chunk, which was all fine and good, and tack it on to what I'm building. Insert something new into that for the fact that this is misspelled and I want to mark it as such. And then continue moving forwards to say, I'll check this word and that's fine, and this one's not. So I could append this one on and this one not so much. And then this brought forth, etc. That looks all okay, so on this continent, blah, blah, blah. So that part is made a little bit tougher because Python out of the gate doesn't have a building construct quite like that for strings. According to the research I've done, and I'll spare you this part, The typical fashion for this is as you would want to create a new bigger string comprised of a bunch of other strings, you typically build up a list of all of those strings and then join them together to form one big like monster string. And that's not a bad paradigm to use in this case. That we'll set ourselves up a list and add things into that list. Some of them will be direct copies of what's in here, and others of them will be, as you would encounter a misspelling, a modification of that to be a separate element that's later on in the list. And when we're done with that big list of strings, we'll glom them all together in that respect. Now, in order to get the things that are in between the words here, including the white spaces and the new lines and the numbers and so forth, we'll need to use a more iterative pattern for this. And for that, I think it's a good idea to come back to one of the functions that we talked about early in the class is like find iter, which sets up an iterable thing in Python that will search out the regular expression and give you back a match object instead. Now, the context that this is used in is to use it in like an iterative context, sort of like, oh, I find up a list of things, but this one will just kick back until it reaches end of inputs, like what the match is in that respect. So this will look more like the following. It's like, okay, finds this thing iteratively in this input string. I think I'm calling this right, but I can't exactly remember, so I may need to sort of look back on that. We'll give it a reload and see what we do. We're going to see largely the same output here because the regular expression hasn't changed. So we'll need to make an adjustment to that regular expression in just a second. Okay, so we'll give it a reload, and then we'll come here. Now I see a bunch of match objects, and actually I didn't do it in this exactly this fashion before. This is super handy because it exposes one of the primary reasons for doing this. So as you look here, you'll see the printed renditions of those match objects. They include, of course, the string itself, like a 4 and score and 7 and years and so forth. But importantly as well, they contain the span of where did this thing start and where did it end. Now, what that's going to enable us to do is to say, oh, if this thing is like spelled fine, then I can either add it in as a fine-looking word or ignore it. It's the case that, like, oh, if I find a not fine word, then the not fine word starts here at position 27. And everything up to, like, the last match, in this case, 0 up to 26, these are characters that I should preserve as is. So copy them right out of the string here into some thing that I'm building up because they can be pasted in. I got being built up exactly like that. Starting at 27, I might make some changes because this thing is actually a misspelled word. And then I might add something there. But when I get that misspelled word demarcated, I add it in the list, and then I move ahead and find some more stuff that is okay, so I can copy that verbatim into the thing that I'm building up, and maybe find some additional stuff that's not so good there. Okay, so that part is a little bit complex, and we might try to address it right now. But it would be good as well to change gears for just a second and talk about, well, how do you even check if a word is good or not? So for that, we'll pull up the dictionary. And that was just a flat text file. It was over here in English Dict, one word per line there. And so to that end, all we really need to do is read this entire thing into some data structure that Python provides and make use of then that data structure to check, is the word I'm looking at now in the dictionary or not? So let's define a function to do that. So load dict file. And I'll give this I'll call it usually abbreviated F name for file name here. Now, if you haven't done any Python file input and outputs, now's a good time just to mention the conventions associated with doing this have changed over time, and they're likely to continue to change as the Pythonistas adjust their flavor and culture of the year and so forth. If I remember right, the current best practices or preferred version is something like the following. Use a with statement, which allows for an action that's associated with a local binding which will actually get into sort of old camel parlance now. But this will be something like open fname for reading. And then the as names this, I'll call it a file here. Now this, you can see my editor indented for it. This is meant to be like, okay, do something here to create a resource, name the resource the following thing. But when we leave this context and sort of come back to this level of indent, the file will be automatically closed. And this is a convenience because I could do a traditional sort of open and then I have to remember to close. Python folks sort of poo-poo that nowadays because this is, quote, the better way. We can sort of talk about that in more detail if you have questions. But for now, this gives me an open file. It's open for reading and it's called file here. So I can make use of additional functionality from that class. One of the beautiful things about Python files is that they're iterable, and the behavior of iterating through them is to import a line from the file, line by line, and allow you to do something with that line before moving in the next iteration to the next line. So a typical reading pattern for a line-by-line file like this is for line in file. You do something with that. Now, of course, we don't want to read a line in, but it's done automatically by virtue of the iteration. So we'll read a line and give it to us bound to line here. Okay, to that end, let's get ourselves some sort of a data structure of sorts here. Now, we're reading in a dictionary, so the first obvious choice is a dictionary. I would actually beg to differ with that. Dictionaries in Python, I think, they're an appropriate data structure for actual dictionaries of here's a word and here's a definition for that word's key value associations. But here, I don't have any definitions. I just want to know, like, is the word present in this collection of things or not? And a set is a beautiful data structure for that. So let's see. Let's go. I'm not even sure. Like, names are always so hard with this because I don't want to pick dict because that's like a reserved word in Python if I remember right. Let's see. We'll call this good words. How's that? Good words. And we'll call this a set. I can't remember if there's an immediate syntax to create a set in Python, but because the open-close braces, I think that creates an empty dictionary, but this set is good enough for it. We'll create one. Okay, so first pass then, we just need good words and some way to add this in. If I remember right, there's is it add? Or plus equals? I can't remember. And the beautiful thing is I don't need to remember. I can come over here and say, here's my good words. And good words is a dot append maybe hi. Nope. How about add? Hey, there it is. Okay, and then good words is hi there. And if I good words add by, and good words look like this. And if I add hi again, good words has set semantics. It only appears there once. So okay, so then we want good words dot add here for line. All right, so that should be in good shape. Oh, we'll probably want to sort of return that good words. Okay, that's something to try out. Want to reload. And then new function, so this will be spell check dot load dict file. Very good. And then I remember right, this is English dict dot text, so it's there. We'll give this thing a name. My dict equals this thing, and then it's probably going to be terrible, but I'll at least just type it in. I'll present some ridiculous amount of junk here. Okay. One annoying thing, there are new lines affixed here. So forget that on iteration, the lines that are read from the file, they are not stripped of the new line that's at the end. I can't remember if there's a built-in Python function to do that, to remove trailing white space or remove trailing white lines. Perl did. That's the last programming environment I had that had functionality like this and would allow you to strip. But Python does provide a nice alternative. I could say up to, but not including the last element in there, and so that should work out all right. Reload, and then let's see. I need to grab this thing. Do I want to? Oh, I wonder if it supports semantics of indexing. So if I said my dict one the up to the 10th elements, would that do that? It does not. Okay, is not subscriptable. Well, thanks, guys. I don't want to do that like whole business. So for X in my dict. Nope, I'm just going to bite the bullet and see if it worked out all right. Here's my dict. And I can interrupt that, and you can see that, yeah, there's slightly different order to things here now that the \n's are gone, probably because the sets are implemented using hash tables, and the keys or the positions in the hash table is computed, including that last new line here. So we get a different first thing here, but this looks about right. And apparently, Kingston's is a correctly spelled word. So well, you learned something at that point. So this one looks about right. In order to proceed with the spell checking, I'm going to add on the dictionary file here. So I'll accept here. Let's see. Should we call it good words again? Yeah, we'll call it good words. That's fine. And then just to sort of, I don't know, test that. Oh, I see. Okay, input is not a good word here. Input is actually a built-in function of Python. So we'll call it instring instead. Instring. That's good. That'll be a good one to remember. Just to sort of get a sense of like where are the misspelled words. Instead of printing out everything here, let's do the following. If, I have to remember the syntax, this is a match object. Match objects are indexable. And so if there were groups in here, I would be able to say, group 1, group 2, group 3, but there's always a 0th group. And this allows me to check the entirety of the match against something. So I can do something like here, the 0th group thing, which is the entire match. If this is not in, learn this syntax, not in, you have to do not M0 in. It's like not in is supported. That's kind of nice because it flows like English text. If it's not in good words, then print, and I'll do that. Let's see, M0 is misspelled. Something like, oh, okay, I got my closing curly there. Use my formatting strings here. So this will print out all the misspelled words that I see so far. I got to reload now. Oh, okay. And then, let's see. Yeah, well, let's see. Setup, my dict is already loaded, so I can go back in history to spell check, check strings, output, input, and we have to add in my dict over here for the dictionary. So this is the new calling interface. Takes a second extra parameter. This is the good words, the dictionary to check in here. And this is looking good, actually. So I have 4 is misspelled, agu is misspelled, father is blah, 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 1863 is misspelled. Okay, so that's fine. And then it returns this, the input string over here, which is fine. I guess I returned none for the moment, but no matter. Okay, this is looking, decent here. Now it's probably time to come back and say, okay, between this this match and the other stuff, I'm gonna have to start copying stuff from the individual input string someplace, and then possibly plopping something down in the other the corrected word in that. So I'll need something to accumulate what I've seen so far, and let's see, let's call this outstring, outstrings, so we'll make it a list here, and this is where we'll build stuff up. Okay, So one possible way around this then, possible way in here is as follows. So every time we get a match, we'll be looking at a word. And if that word is in the dictionary, we'll do one thing. If it's not, we'll do a separate thing. So let's deal with the in the good words part. I'll keep this printing message down here so that we can use it later. Hey, back off the indentation, bub. Okay. So if it is a correctly spelled word, we just want to copy it verbatim. And I'm going to do this slightly wrong, but then refine as we go forwards. So I'll plop down outstrings.append this M0. Else we'll do, we'll print out the thing, but we'll also have outstrings.append M0, but we'll append a slightly different version of it. We'll format this as the eventual output format for our demarcation of misspelled words to start with here. Okay, so that'll create a new string that's based on this M0, but plop some asterisks down around it. In terms then of like my eventual out string, I've got all these out strings over here. And so then what I'd want is a way to say make one big string that concatenates all of these together. If you bop around in the library files, you'll find there is a way to do this using a string method. Now, if I remember right, this will be something like if I join a list of strings like A and B and C. So you'd have to sort of look back at the documentation and find this is the way to do it. This will create an ABC string. I think joining with commas. This is the delimiter that gets inserted in between the strings. And so this will be a way then to say, oh, I've got constructed a list of strings. I've appended correctly spelled words. I've appended incorrectly spelled words. And then I'll join them together at the end to produce the output string here. So outstring equals outstring. See here, I'll join them using this out join out strings. And of course, I could, just return that, but for the moment, we'll just leave a single local variable up here. But that's the result of that, because we may want to do something with that in a second. Now, observant folks will sort of recognize, oh, this is going to be wrong, but at least for now, we have a start. In fact, to make it a little bit more obvious, let's put a space here, so we'll space separate these things here. Okay, let me pull back my reload. Reload. Too far forwards in history, I guess. There it is. Reload spell check. Got a new thing. Let's see, where are we at here? This, give him a call. We'll get some rings. And now you see something that's reasonably close, actually. 407 years ago, our fathers. Hey, this is not bad, some things that are missing here to the pieces. All of the punctuation is missing because my original regular expression, it didn't match any punctuation. And so there's no possibility of that being in there. It's marking like these numbers as misspelled, which isn't great. And I've lost all the line breaks. There used to be sort of new lines in here at the end of some of these lines, and those are all missing here. So that leads us to then the sort of final iteration of this part, which is to say, well, how do I account for that stuff that's in between matches up there? This is where the match itself and the fact that it tracks a span is going to be useful. So we can massage some things there and I don't know, pull that, utilize the capability of I can index for certain of these into my original string and copy stuff out of that. I'm going to pull back in my command history here to remind the span stuff here, This word was from 0 and ended not at position 4, but before position 4. And then there was a space that occurred after it here. That was the index 4 ending at index 5. So then at index 5, this score starts here. And so this speaks to a certain kind of logic to say, like, oh, if I'm going to build up this string of output down here, then I can visit each of these words and sort of pop them down, but then also grab things that are in between that stuff. For that, I'm going to need to do a little bit by way of modifying the loop so I can look back and find where my last match was. I've seen this kind of code pattern before, so the typical way, you set up like some sort of index here, like a last index, and we'll set it at 0 to begin with. And then each iteration, I'm going to get a substring that precedes the up to the last match. So here's prefix. And this is going to be the original in string. It'll be indexed from the last index. This is the last index that I looked at up to the first index of where this match started. And you can see over here it's got this span. I'm trying to remember if there's an indexing for this that's a little bit more salient. I just want the starting point at that point, and the ending point is we'll need that as well here. What's a quick way to do that? It's probably just to look it up. So let me grab a Chrome tab here and search for the Python RE module. I'm sure there's some built-in documentation somewhere. Oh yeah, I could actually use the built-in documentation. So help on RE. No. Help RE. Hey, there we go. There's the Python module. Okay. So what I'm looking for here is for the match objects. Oh boy, it is really long. Let me search for reload back a little ways here. What I'm looking for is that span business. Okay. For a match object, return a 2-tuple of start group end group. Okay. And it looks like it defaults to group 0. So what I want here is, let's see, we'll say start, stop, do a little structural destructuring here. And here's my m.span. And just to get an idea of this thing here, we can, well actually I can see it back up in the match output that we had. It's going to be way back up here. Match objects. Okay, span is... I can't even remember why I was looking at this here. So this will be with the start part. So I want to fish out of the strings if I had matched and. I want to take all the things from whatever the last match was up to, but not including and here. So that'll be the start part of this. So last index up to start. So this gives me a prefix that preceded whatever the first match was, or the last match was. The stuff between the last time I looked at a word and inserted it into this growing out strings over here, and now I'm looking at another word and I'm styled here, but this will be what's in between it. So for the sake of clarity, let's print that out as. Let's see, prefix is, and then I'll use here some quotes so you can actually see if there's white space between it. Prefix, like this, and that should be good. Okay, no further action at this point on that part, so that's good. I'll need to reload again and do run again. So prefix, okay, so we'll start up at the top here. So the initial prefix is empty, and then the prefix is 4, and then the 4 score, 470 years, 4 to go, etc., etc. Now, part of the reason that this continues to grow upwards is that I never bothered to change last index, and my original intent, forgot to do this, is as I iterate forwards, last index moves forwards and becomes like, oh, the last regex like stopped here, so I'll update the last index with that. But you can kind of sort of see here is like, oh, I'm taking progressive prefixes here. But if I make a modification to say last index each loop iteration will update to stop over there, and then reload and rerun, then you get, it's hard here because I think we'll just print out the match 0 as well. Print prefix, and over here match as M0. So indicate then that what's in front of the match that we've got. I'm going to reload that, and then print out here. So the stuff that appeared before Lincoln is this. The stuff that appeared before Abraham was this gobbledygook here. And this is including a line break, because if you look back up at this, it's like, isn't this a great speech? Exclamation mark, there's a line break, a second line break, and then the Abraham appears. So this is going to allow me to capture stuff that's in between the matches as well and insert it in there. And I can do that very simply just by saying, oh, unequivocally, by every iteration, take this prefix and add it into the outstrings. Outstrings, let's see, dot append prefix. Okay, so that's feeling reasonably okay. One thing we do right now is just have a look here and see. Let's comment out some of the, wow, this will be noisy like outputs because it happens on every line. You can at least see the misspelled words here and then see how we do here. Reload on that, and then we've got the append of the prefix and append of both the word and the modified word there, which should be good. Okay, and then here's our output over here. Looks a little funky for some reason. It looks like there's 2 spaces between each of them, which was undesirable. Okay, see if we can debug that part. I'll actually probably pause here because it'll take me a second to suss out like why it is. It's very suspicious that there's a 0th element here. And to that end, I'm wondering if I have like an off by 1 error. Let's see, I'm curious if I have a string that's like equals 4 score. Oh, and it says 4 is misspelled. That's also like a little bit odd. I wonder if it's getting something a bit off in that regard. Let's see, because I spelled checked match 0. Okay, but if I take S, so the first prefix would be the 0th to the 0th here, because the first match starts at 0, and the last index is set as 0. So if I take that, it's an empty string, which is what I would want there. Okay. We had a match here. I didn't monkey the string. Oh, is it actually... Hang on, man. There might be an extra space there because of confoolery with the... let's see... Oh, not RE, spell check, sorry. Because of confoolery with the line break. No, it looks totally fine. So interesting. Okay. Well, this is the old debugging. So this is going to take me a little bit of pondering and experimentation. I'm going to pause while I do so. Well, of course, I'm a moron. Earlier on, for clarity, we decided to do our string join using a space for the separator. But now is the time to remove the extra spaces because we're accounting for those spaces ourselves now by looking on the in-betweens. That's essentially why the initial, like the extra space show up here. I'm not sure about this 4 part. Oh, but I bet. Okay, I have an idea about that too. Okay, we'll come back to that in just a second here. Okay, spell check. So that with that change here to remove the additional spaces, then we'll do a reload and then a rerun, and so this is starting to look pretty sane. If I do some string wrapping here, I see some embedded new lines, and so if I did something like just print this, then see the output up here, but this stuff is looking kind of decent. Let me take off the word wrapping. Yeah, this looks like it's matching pretty well so far. The line break, the continent is the first, the proposition is the first line, and Abraham, good. Okay, so this is actually like very positive so far. Now there's this bit about for here. There are a couple possibilities. We might have code that's wrong here, but it's good to check data as well. And to that end, come back over to that dictionary file, the English dictionary. And let's just check, is for in here? It is, but it is lowercase. And all we check for is uppercase, or it's like a mixed case here. And so it'll be a good idea then to deal with casing by consistently upcasing everything or lowercasing everything. And to that end, we'll need to revisit both spots because we want to match in that respect. In our dictionary, we'll want to upcase. I prefer upcasing, like it just looks more official somehow. So capitalize the entire thing. Let's see. I have to try to remember if there's a function that does this. I'm going to take a pot shot and say, hey, do you have a string class here that I can know help on strings? Is there a string module? Okay, I don't suppose you'll take me back up here to the help part. Yeah, good. Okay, so we're looking for uppercase maybe. There's a bunch of stuff here. Maybe upcase. Nope. Okay, well, let's just Google for it. Say Python uppercase string. Oh, it's just upper. Okay, that's fine. And so if we'd have, Apple, actually let's do for dot upper, ta-da, it's uppercase. So these are the ones then that we will plop down. So we'll take the line, and after we substring it and move that, it'll be upper. And then here we'll want to check for the uppercase version in the dictionary. I'm trying to find if M0 is in good words. 0.upper is in good words. Now strings dot append this, otherwise do the misspelling thing. Okay, cool. So that should fix up the for problem as it being recognized incorrectly. Oh god. Well, everything's misspelled now. So what did I do wrong here? Oh, of course, I've got mutable state. The dictionary that I loaded earlier needs to be reloaded because it's not upcased. So let's see if I can find that in my command history, load dict file here, and then we'll give that a run again. Hey, this is looking pretty slick here. Okay, 4 score and 7 years ago, etc. And peeps, and then my numbers are being misspelled. Now, this word, this stems from the regular expression part, and the isn't part, that also stems from the regular expression. So it might be time to massage that part. Long story short, I don't know a whiz-bang solution for this, but through some experimentation, I found that if you pick letters like A down to Z and single quote, this will exclude any of the number things down here, and also account for checking the whole word with the single quote in it for contractions for spelling there. And so that minor adjustment to the regular expression means we will check the words, the slightly different set of words now as we iterate through, and that should lead to more positive results, at least for isn't, maybe so for this other stuff down here. So let me do a reload here for that part. Dictionary didn't change, but the spell check function did. And whew, okay, that's not good. Oh, that's because I did forgot my little plus here to say one or more of these. That's the actual word. Give it another reload, another print, and I think we're in good shape here, but the observant folks will notice that I lost my numbers here. That's on account of at the end of this input, these are not matches, and there's nothing after this loop that would capture an ending sequence over here that isn't actually a word that's either correct or incorrect. It's a non-word. It's other stuff. So to that end, let's make one minor correction here. So after our for loop is done, we have a last index set. That is the index of the very last match that was in there. And we'll need to append one final thing to this, which is the outstrings dot appends. It's the in string. It's let's see, last index up to its last element. I'm trying to remember. Will that capture the last thing here? Let's check. Okay, so I've got an S. We'll make it. We'll do 3, 4, 5, 6, 7, 8. Maybe I'll put a 0 here for that. Last index, we'll say it's equal to 3. And then S, last index up to its minus 1th element. Misses the last one. Okay, so how do I say the last one? Is it going to be len of S probably? Yeah, okay, so that's good enough. Not its last, but it's len of S. Okay, so that should tack on the ending part that was missing there. You gotta reload. Oh, come on, guys. Reload, there it is. Oh, shoot, never closed. No problem, I'll close it for you. And then, oh, that's not really the one I wanted. Name S is not defined because it's not called S here in string. Load, rerun. Hey, okay, and this captured the numbers and the additional new line that was at the end of it. So I think we're in pretty good shape at this point. All right. Refinements of this particular part of it. Firstly, we're plopping down a lot of things into this list, and with a little bit of reasoning, you can surmise, actually I could skip this whole good words business and just plop down things that are in between bad words. I'm not going to bother with that right now because it's not terribly important to the logic of this. It would just be a minor efficiency part. It would also be interesting to sort of look at this in a file context because you can see this as like, oh, basically I could feed in here, as I did for the loading the dictionary, lines to this spell checker that are coming from the file. So I don't need to do it across the entire string, just line at a time, and then output a line into an output file. And we may get there at some point in that respect. Let's see. What I do want to focus on is, okay, this part down here could use a little massaging because I'd like to give an opportunity to actually correct the words. And that's actually going to be a useful application of higher order functions. Before we do that, though, it'd be a good idea just to get this onto the command line so we can actually run it there. For that, I'm going to follow the usual convention of defining a main function where we'll do our stuff. And then later on down here, we'll have the, let's see, what is underscore name equals, what is it, main? Main, I think. I'm going to have to probably cheat at some point. I'm remembering now. It's underscore main. This means this module is being run at the as the sort of entry point for the program, then call main. Now, here's where we're going to need to understand a little bit about the command line processing associated with Python programs. So I'm just going to print here in main, and then we'll be able to see, I'm going to bop out of Python at this point back into my normal shell here. And if I run on Python this spellcheck.py. We've got in main, so we've got a main function that's running here. But I'd like to be able to pass in, hey, spell check this file, use this dictionary file for it, as well as potentially some other information that's useful. To that end, you need to know about where Python picks up command line arguments. Quick Googling will get you this, but let's see. If I remember right, it's in the sys, the sys module, and I think there's an args there, so print sys.args. So now I don't need to reload because I'm just rerunning the script, and I was wrong. Did I mean argv? Yes, I did, in fact. You guys all call it things differently. Java wants it this way, and C wants it this way, etc. Argv. So here we are. So spellcheck.py is the sole command line argument. This is presented as a list. So indexable from 0. You can sort of think of a spell check as the program name that's being run. If I ran with more things like arg1, actually we may as well do it right here. So here's Gettysburg misspelled and English dict.org. You can see those get passed in as command line arguments. And so I can do things like check to make sure that an appropriate number of command line arguments have been passed in. In this case, there will always be a 0th command line argument, which is the name of the program that's being run, Python script in this case. But I want to enforce that there is a 1th and a 2th argument as well, because I need a file to work on as well as a dictionary that is used for my good words. And so here at this point, let's see. Okay, well, I just need to check if the length of sys.argv is less than 3. Let's see, it's less than 3. Then I'd print a usage of, this is a format string of argv 0. And then here is typically like data. .txt, then run and dictionary .txt, something like that. Okay, and just to make sure that that's working okay, we got through there is fine. But if I left off the dictionary file, argv, sys.argv, sorry, sys.argv. We're good. Okay, so then we get the usage meshes here. We could probably start laying off this part. I tend to, after finding all's well and good, or if it's bad, then I'll return at this point, or exit or something like that. And here I'll name my command line arguments so I know for sure, like the data file equals sys.argv, the 1th, and here the dict file is argv2. Okay, we're now in a position to actually call these functions in the script. So I'll say here good words equals load dict file of dict file, and then out string equals how do I call it, in string good words. Let's see. Oh shoot, okay, I need to get the input string from that. Well, okay, let's hack just a little bit here. What I'd really like to do is to convert the file into a string, and that will then spare me the need to do anything special with this spell check function. For that, we'll need some filey business. And I want to do a slurp, essentially. There's no reason that you would need to know what a slurp is. It's basically read the entire contents of the file into a string. Here's how to set one up in Python. You can Google for it. I might do it wrong, but no matter here. Slurp on fname. Let's see, this will be with, let's see, open fname for reading as file. We'll set here string, say file string. That's good enough. File string equals file.read. You'll probably see in a lot of places in the Python manual, this is bad, don't do this, read it line by line. Like, who cares? We're not shooting for optimality right now, but it's correct that you'd want to process a file line by line. If it's a gigabyte long file, then you'll have used a gigabyte of heap space as you read the entire thing in. That all you're going to do is go line by line anyway. So you may as well read one line at a time, leaving the memory footprint of your program much lower on that account because you don't need to store the entire file in it at once. We're playing here, so pay that no mind. Let's see, file string use, and then return file string. I think that works out okay. There might be some shortcuts on it, but this is good enough for now. So that allows us to slurp. Actually, let's just check that quick so that we're okay. Here's Python, and we'll import spell check. Spell check, invalid syntax, out string. Oh, shoot. I'm getting ahead of myself here. Let's see, how about now? Do you like it? Okay, cool. And then if I s equals spell check dot slurp. What's the name of it? Gettysburg misspelled. It's good, and S is the entirety of this thing. So cool. So this is useful to just sort of make things work together for the moment, and we could deal with more efficient file processing later. So then the in string will equal slurp of my data file. Now, let's see. Well, we got to call the function for it. So out string is this follows. I'm looking for, what was it called? Spell check string. So it's down here. Spell check string. The string to check is in string. The dictionary to use is good words. And then we'll just, for the moment, print out string. I'll print corrected. All right, let's see how this looks. Gotta get out of Python, back to the shell, and then find here this bit of business. I forgot my dictionary, so there's English dictionary. All right, not too bad. We've got some lingering output over here, like in main. We can get rid of that. I mean, we could like sort of attend to each of these like by commenting out the output. I actually kind of like it like right now. So, I don't know. We'll deal with that later. But here, like if we can figure out a way to pump this into a file, then we'd be fine. I mean, you could use the good old-fashioned Unix indirections for the x.txt like here. No outputs, but if I look in my directory now, I've got my x.input, which is approximately what I want there. And if I had cut out the additional stuff, that'd be fine. But this, then I'd have more or less what I wanted. It'd be a command line filter more so than creating the output file. At any rate, that's probably sufficient for the moment in terms of the basic functionality of like spell checking and correcting, because I can get it into an output file in more or less some form or another. It's time to change gears just a little bit and sort of recognize how you would make this program somewhat more flexible. One could envision several different use cases. Either this is used by some editor to sort of rifle through some text and mark these as misspellings that someone else has to deal with. Another would be I might actually want to give the user an opportunity to correct it on the fly, like before the output happens. Third might be just apply some heuristic to automatically correct words as you would see them. And maybe someone come back later and sort of verify that. Maybe they don't care. You just sort of accept whatever the closest word match is or something like that. There are lots of different spots there, but essentially it boils down to the corrective behavior of once I've identified a bad word, like what do I do with it? That's the part that is variable in there. this is a good spot to start exploring use of higher order functions to sort of insert something in there that is sort of modifiable. So it's this behavior right here, the I found a bad word, what do I do with it, in that respect. That's the part where we'd actually, kind of like to make some changes potentially for it. So let's just abstract away that part and plop it down in a function that becomes a parameter to spell check over here. So the way that I typically do that to start opening this up to further changes is as follows. We'll define this behavior as a function. Need some parameters and so forth, but that's fine. Yeah, something like that is good enough. So here we'll say, we'll call this mark bad word. And we'll say, here's the bad word. And the purpose of this function is going to be to decorate this bad word and return the decorated string. So over here, I'm just going to lift this part. And all I will do is return this. Now, the presumptions here are that bad word is one that is misspelled. It's been identified as such with the dictionary. We may want to monkey with that a little bit right now, because already I'm looking at this and thinking like, well, do we actually want to abstract away like this condition as well and just say there's a checking of words here that happens, so we'll pass the dictionary in. We'll consider that in a second, but this is one possible path to mark up here. So with that in mind, then this becomes a sort of flexible thing that will return some demarcation that you can imagine, replacing these with underscores to like in some other ways or something like that. But essentially, we down here just need to plop down some stuff like the following. What would I plop in there? I'd set up a local variable, say kind of corrected word equals. Now here's the crux where we'll actually get the higher order function thing. I'll call this correct fun, and this isn't defined yet, but we'll introduce this as a parameter for the function, and corrected word right here. So this will be now a function that comes in correct fun. And by default, to preserve our present functionality, I'm always going to pass in mark bad word because it's the only one that really fulfills the requirement, but this will give us an opportunity to add some flavor to this. So I changed the calling convention here for smart spell check string. Come down here to that, and I'll say mark bad word down here. Nothing from the outward side has changed. It's just the internal structure is altered a little bit. Fancy term for that, refactored. And so if you're just putzing with the code, you can tell your boss, I'm refactoring right now. You're like, ooh, okay, I'll leave you alone. Let's see. Of course, this didn't work out because I forgot to correct. It's called bad word in this context. So let me get rid of the M0 here, bad word. M0 is passed in correctly to the correct fun, so that'll come up here to bad word, etc. Now we're getting a little spaghetti-esque, but no matter. And yeah, okay, so we've got the same basic functionality, and we're in a position now that we can start to play with the fact that now I've got a tweakable knob in here. For instance, one thing someone might want to do is to actually make the corrections. So we can plop down here, see mark bad word, we'll say correct bad word. Instead, here's bad word. And I could do something like print. Actually, we get really sick. I don't think, frick. Okay, so this is called input in here. Let me call it in string. Can't remember if I used input anywhere, but I now need the name input for the built-in Python function. So input, and we'll pass that a formatted string of here bad word is misspelled. Correction. And we'll leave that as the prompt for the user to input something. And we'll need to give that correction equals this, or maybe correct word. Could spell it right. And then return correct word. Of course, you can elide the whole like local variable thing. This would allow us to do something like print out a message like, let's see, replacing with correct word here. Okay, and so that's why you might have a local binding of that thing. And now we've got a choice. Do we want to use mark bad word or mark correct word? Well, let's first test to make sure that correct word is correct bad word works as intended. So ago is misspelled. Let's guess for ago. Pathers is misspelled as fathers. Fathers, liberty, liberty maybe. Proposition, maybe. Okay. People, something like that. And here in the corrected one, hey, look at that. It's corrected here. Now the obvious choice is, well, I've got two different things now. Like, which one should I use? And how would I enable a user to select which of these two to run? Obviously, you need a little bit more input from the user, and a common way is to add another parameter. So correct fun down here. Now we've got a little bit of a conundrum wherein, okay, I've got these different options for correct fun, like how do I expose that? They're function names. The easiest way is like, well, let's have a dictionary of that. Like we'll define the correct funds as, there's a string, let's see, we'll call it correct, let's see, mark, and we'll associate it with correct, let's see, mark bad word, and then here, correct, and that's correct, bad word, something like this, okay. And now we can take a third command line argument. This one's optional. So it'd say here by default, we'll say by default the correct fun string will equal mark. But then if there happens to be so the length of sys.argv is greater than equal to 3, then let's say, sorry, yeah, it's greater than 3, sorry, because I want the third index. Then I can set my correct fun equal to whatever that sys.argv 3 is. So that'll be the optional parameter. I can get rid of this extra thing here. Now that I've got that, I can look up in the dictionary correct fun equals, here's the, let's say I've got my correct funds, and I'll look up the, sorry, I want correct fun, I want correct stir, correct funds, correct fun stir. Probably could have picked better names for these things, but you know, your mileage may vary there. And now we've just got our correct fun in here. That's a parameter that's been determined by the command line interface. It might be a good idea to notify a user, like what are the options for this. I could do that, you know, verbatim, but I also try to be a little bit clever about it. The possible options are mark and correct. These are keys that are in the dictionary of the Python. So I could do something like, let's see, I need to remember what the exact syntax is for this. So let me, I don't even bother to reload or anything. I'll just punch that in. Oh, of course it's not. Those things are not correct. Okay, well, we can do the following. Here's 1 and 2 are undefined. And then you're just going to give me this bad indentation crap, aren't you? Oh, of course. I'm back in OCaml. There's no def. Because it's not a function. Okay, well, that's good to know. Okay, so then I think it's like, is it keys of correct funds? There's a built-in. Nope, it's correct fund dot funds dot keys. Yes, it is. So dict keys thing. Can I make that a list? Okay, so that's probably good enough. And I could even do then comma dot join of this, and then it'll give me a string that's like that, and maybe a comma space join. Hey, that's pretty good. Okay, and so that part here, I'm gonna jump over here in my usage meshes and say print. Let's see, not let. No camel here. Let's see, funsters equals this thing, and printf here the usage. I just want to notify users that these are valid, so something like correct fun is one of, and then these funsters. Okay, and then that's an immediate return. Out of Python, back into running this gobbledygook, and as a usage message, I just need that is one of mark and correct. Cool. Okay. So if I pick mark now, I need the English dictionary. English dictionary, and we'll say mark here. Okay. Sys.argv. Stupid syntax here. Here, len parentheses. That's fine. And argv instead of args v. Okay, so that's the mark version here where the misspellings have been marked. And then if I pick correct, hey, we got it. Okay. One thing I find irritating about this stuff is, I mean, this is a minor refinement, is that I'd like to, but just punch enter in case something is there. So let's see, if the correct word is equal to empty string, then correct word will equal bad word. And so that'll let me punch enter to sort of jump through these things. So that's another addition. Let's see. We'll call it smart correct. And the smart correct here, we just need to add it in to this part. Let's see, and I guess I will follow the more reasonable Python convention of here. Smart correct. Now, of course, it'd be nice to have like some additional context, like what the hell are these things? But you can see the pattern here and refine it as you would want. Just to sort of nix this thing to make sure. Nope, didn't quite get that right. Invalid syntax someplace, probably because I forgot commas here. Okay. And hey, I've got smart online. Let's try it out. Smart. Don't care. Propositions are solved. Let's see, and replace proposition with proposition, etc. And so I can just sort of like skip through those things in the case of that. The final thing that I think is kind of interesting to look at is, as you would be misspelling, there's like no context for the misspelled word here. And in that regard, it would be nice to get sort of like, well, where is this word appearing, like in the line or something like that? There are a bunch of variations for this, but all of them would potentially involve the following bit. You change the interface to whatever your correctant function is, possibly passing it more information, like here's a subset of the text that's around it, and then each of these functions would need to change its calling convention over here. Python's optional arguments are nice for this. Is that like, oh, maybe I don't care if I'm passing, I get a default thing that's empty or something like that. But one particularly slick thing that you could do in terms of, I don't know exactly what kind of misspellings like I want to, or what kind of context I want to provide to this thing, is the following enormous hack. So if you recall, this locals function exploits the dynamic nature of Python to pass in all of the local variables to this spell check function. That means what will come in as a second argument to correct fun, whatever it is a dictionary that contains things like start and stop and regex and out strings and last index and in strings and good words and correct fun and so forth. To demonstrate that and its utility, and we've broken all of the like other things, so let's fix those quickly as they take a second parameter. I want to add one sort of last modulation of this, a correction part of it. So let's call this ignore and paste that over everywhere here. Ignore, and that was all three of them. Okay. So I just want to make sure this is working, and then we'll start exploiting that part. So here's smart, and it works like as intended. Here's correct or mark, and it spits that stuff out. So I think we're good to go there. Okay. So let's take our smart correct and expand it just a little bit. Smart context. So this last part, I'll call it loc. Or VARs. VARs is a built-in. I don't want to mess with that. Okay, we'll call it locs for short for local variables. For instance, what's something from this local context that might be sort of interesting? We've got start and stop. That's where the match is at. So let's do something like the following. If you want a little bit of context, let's first grab out from this locs, which is all local variables over here. It's in a dictionary, so locs within this, it'll be called. Okay, let's do it in the following way. Let's see, we need in string to grab that over from this thing. So I'll grab that from locs. It should be called in string. I want the start and the stop. So I'll just basically wash, rinse, and repeat this. So here, replace in string with stop. Here, replace in string with start. We're good to go. So we'll fish out those things from the local variables that's over there. Just to prove like sort of what's happening here, I will print. Let's see. Let's just do it. Like we're gonna eventually remove this, so doesn't matter overly. Here's start and stop. So this is a local variable from another function that we passed in via a dictionary of locals. Like truly awful like programming form, but tremendously convenient in this case, and makes it exploitable from the Python context, makes it sort of nice to sort of observe how the dynamic features of Python can factor in here. That I don't need to figure out ahead of time what local variables are coming in, what kind of context I need here. I just pass the entire context over to it. So we'll need to add this smart context in, we'll just call it context down here. So context. So all this is going to do right now is to print out something that's a little bit more verbose, because there'll be those start stops that are on there. And if I am correct, should just be able to say context here. Okay, so there's my 2731. They are where this agu is found. It's matched, and there's a 3643, etc., etc. And so that gives me the ability then up here to say the following. So we printed this out. What I want is to get a substring of in-string. So context string, it could be in-string. I have to be a little bit careful here. So normally I do something like, start minus 15 up to stop plus 15. This may actually go out of bounds of the string, so I'm just trying to think if I want to do this as a giant hack in here or something else. Let's do it in this way. So we want the start to be the min of 0, and let's say min of the max of 0 and this thing, because we don't want to go under 0. And stop will be the min of length of the in string, and then this other thing that was the end of the stop. So if it ends before the end of the string, but we're fine. So now we've got shoot. Okay, we want this minus 15 and this plus 15. In fact, let's call that, here's our width is 15 so that we can make it symmetric. Width, and this is plus width. Okay, now I have a safe start and stop that gives me some context around this. And here I'll say this will just be the context string. So this will print ahead of the prompt and give me an idea of where this stuff is coming in. Keyboard input, don't care, is context, and here's a goo. So here it is. And so this gives me a little bit better idea. I might try a little bit higher width than that, maybe 20. And I got to be cognizant of line breaks here. This is where if I was going line by line, it'd be easy because I could just print the entire line instead, but no matter on that account. And then maybe we'll do as well, let's see, print, always using the format strings, .. and context string, .. and end here. And then we're, I think, good to go. So something 7 years ago, our fathers, blah, blah, blah. So the correction would be a go. And the next one, even 7 years ago, our fathers. Oh, so here's something that's kind of crappy is that I'm not getting the new context of I corrected a go or a goo to a go there. So that would be a further sort of interesting refinement because I'm always referencing back into the original misspelled strings stuff. But no matter. But this is pretty good. So this would be fathers. And then if I don't care too much about the remainder of these, I at least got the fourscore 70 years ago, our fathers brought forth on this continent, new nation, blah, 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 precision, etc. So, okay, so I think I'm exhausted at this point. It's about 4 times as long as I thought it would go, but hey, that's live coding exercises for you. Hopefully this gave you an appreciation for some of the practicalities associated with using the tools that we've introduced in the class. Regular expression matching is awesome, but it requires some careful sort of attention to detail about how you'd actually construct a reformatted text and so forth. And higher order functions, like the ability to pass in hooks, functions that get called when certain events occur, that's incredibly useful, and I've used it many times over. And lots of code environments like Emacs and probably VS Code as well will use hooks or callbacks. They show up in GUI environments all the time like this, and they allow then for some amount of customization to say like this and growth of code to say, what I've got is some general purpose logic and then a bunch of knobs that I can sort of turn in different directions within that. And to that end, higher order functions make that really easy to do. I will now sign off at this point just by saying I'll make sure to update the code pack to have this live demo version, which is somewhat different from the solution I concocted myself on the top level directory of that part. But apes like similar things. If you're curious about in here about the the output part, there's stuff that attends to like the outputs within this function as well. But a lot of the structure is going to be sort of similar there. But the commenting is a lot better. I should mention that one of the nice things about Python, we saw there's built-in help. So as you would say, let me change up directory so you can see this. Right? As you can say like, oh, I need help on strings, and this will in the interactive loop like throw at you what essentially appears as a web page in the online documentation. If you format the comments or the comments and doc strings in your own code appropriately, and the convention in Python is every function should have a doc string, triple quotes string. That's the first thing that appears, and it becomes a help documentation for it. Then the Python system will actually produce documentation for you for that. I'm trying to remember if I have to import it first or not, but if I did help right now on spell check, which is the module. Oh yeah, but here's like look at this nicely formatted documentation. It looks like a bona fide like manual page or something like that, and it's just being extracted from the commentary I have in the code itself from these little buggers over here. Gives the context for this stuff. I think it's in alphabetic order, so like if I look for load words here, like this documentation is provided like here is the doc string associated with this thing. So you can also apply then top level documentation for the entire module, which gets nicely formatted over here. So that's another nice trick to know about as you're working, because you can save yourself some headaches later on for stuff. All right, that's all I've got. I promise. I'm signing off. Happy hacking all, and I'll see you in lecture next week for more OCaml.